Here's my video for lab 6 or on servo motors. Here is my circuit board, potentiometer connected, and right now as according to the lab, the servo motor is not connected because the Arduino is unplugged. So I'm going to demonstrate how the potentiometer here is going to work my servo motor. So by connecting it, I'm going to plug the digital PWM signal 7, plug 5 volts in, which I have connected from here in the Arduino, and then having common ground with the Arduino here. Okay. Now, as it says here, I'm going to power up the Arduino. So we're going to plug it in. And then here's the motor right there. And it says to show how it's going all over the full range. So code is uploading, just making sure. So I'm going to turn the potentiometer, which should turn my motor. The full 180. Serial monitor just showing when I change how the angles will be changing based off how when I turn this, the numbers will change, showing what angle my servo motor is at. So here is my code for the lab. I start off by defining variables to 0 to start, just so everything starts except for my pulse, which is the pulse time constant, which for my motor is 20,000. So here I'm assigning digital pin as waiting to be assigned. I'm assigning the analog pin to read the value as an input, and then starts the serial monitor at this speed. Okay, so I'm going to reassign this variable to be the value from the potentiometer, so it's reading what analog values coming from the potentiometer. T control here, it's going to map. So its map is taking that value here, and it usually goes from 0 to 1023. Instead, it's going to convert it to go from 567 to 2400. This is because my servo motor cannot understand 0 to 1023. That's not the negative 90 to 90 angles, so it needs to be anything that will be able to read, understand, and not overpower my motor. Here, we're going to write it as high, to set the digital pin to high. This way, we're going to start creating the duty cycle. So it's going to be high, and it's going to delay this much, and then go down to low for this much. This is just creating the duty cycle for how high it should be to compare to how low it should be. And then we're going to convert the angle here. And the angle is going to be the map. That value is going to equal the T control value here, and it's going to be between the two values I had here to negative 90 and 90, just to show what the net value of angle is. Like this correlates this, and this correlates this. So that way it's not these random two numbers, it's an actual angle value that makes sense for a servo motor, as I wrote here. Here I'm just printing all the values. So the angle value is going to print this value here, which again I'm saying is converting from these two to these two. And here's convert my time control, which is the analog value of whatever angle it is between this is my low, this is my high. And then we're going to delay it, the time constant minus whatever my time control analog value is. And that's my code. We just did 5 volts to here, my ground is here, and then my potentiometer. So here it's being connected here, this is plugged to the ground, this is getting power to the potentiometer, powering through the Arduino. The gray wire here is connected to A1. So this is A1 is reading whatever value it's reading here. And then of course my servo motor is connected to the ground and the power, and then it's getting its value if it's on or off from pin 7 through to this one based off of that. And then it's plugged in.